All right, today we're diving into something really cool. It's a breakthrough AI from Alibaba called Qwen3-Next. And look, this isn't just another big model getting bigger. It's a total shift in how we even think about artificial intelligence.
So let me just start with this question. What if an AI could have this enormous, powerful brain, but to solve your specific problem, it only needed to use a tiny, hyper-focused part of it? That core idea, right there, is the secret sauce that makes Qwen3 such a revolution.
You know, for the longest time, the AI world has been stuck in this wild arms race. The whole mantra was just bigger is better. But that race for more and more parameters came with insane costs and unbelievable energy demands. Honestly, we were hitting a brick wall.
But what if that entire philosophy is just wrong? What if the future of AI isn't about more brute force, but about being more elegant, more efficient, just smarter? That's exactly where this new wave of models is taking us. The key difference really boils down to this: dense models versus sparse models. A traditional dense model is like using your entire brain just to decide if you want coffee or tea. It's complete overkill, right? But a sparse model, like Qwen3-Next, is way more clever. It activates only the exact little cluster of neurons it needs for that one job. And the magic behind this is a technology called mixture of experts, or MoE for short. Instead of one giant AI trying to be a jack of all trades, an MoE model is like having a whole team of specialists. When a problem comes in, a little router inside intelligently says, "Aha, this one's for the coding expert," and sends it to the right one for the job.
An even simpler way to think about it is like a huge toolbox. If you need to hang a picture, you're not going to drag out the saw, the wrench, and the drill, right? No, you just grab the hammer. That's exactly how Qwen3 works. It picks the one perfect tool it needs.
And the efficiency this creates is just staggering. Get this number. At any given moment, over 96% of the model is just sitting idle, doing nothing. So even though it has 80 billion parameters in total, it only ever activates about 3 billion of them to give you an answer. That level of efficiency isn't just an improvement, it's a complete game changer. But being super efficient is only half the story. The other key innovation here is something they're calling hybrid attention. And this is the model's secret weapon for understanding enormous chunks of text. I'm talking entire books or dense legal documents without ever losing track of what's going on. It works in this really clever two-step process. First, it does a quick, broad scan of the whole document to get the big picture, the main themes, the overall structure. Then it uses a kind of laser-focused attention to zoom in and pinpoint very specific, crucial details from anywhere in that text. This approach makes it both lightning fast and incredibly precise. So the architecture on paper sounds absolutely brilliant. It's smart, it's efficient, but the billion-dollar question is, does this radical new design actually perform when the rubber meets the road? How does it stack up against the heavyweights? Well, let's look at the results. First up, a major coding challenge. On the human-eval benchmark, which is a notoriously tough test of code generation, Qwen3 scores an incredible 92%. Now, that's not just matching the competition, that's actually surpassing the well-known GPT-4. We're seeing top-tier performance from a model that uses just a fraction of the resources. It's insane. And remember that hybrid attention we just talked about? Here's where it really flexes. One user fed it the entirety of War and Peace, one of the longest novels ever written, and asked it to track characters from the very first chapter to the very last. And Qwen3 nailed it, proving it can process and recall information across an absolutely massive amount of text. Its reasoning power is also on another level. When you throw complex logic puzzles at it, it excels where its older, denser cousins just fail. But what's really impressive is this. On a puzzle that was intentionally unsolvable, it correctly identified that no solution existed. The other model just got stuck in a loop. That's a huge leap beyond simple pattern matching. That's genuine deduction. So let's be crystal clear. All of this top-tier performance in coding, in long-form understanding, and in pure logic is achieved with an efficiency that is just, well, mind-blowing. Let's break down what that really means in practice.
First up, speed. It's more than 10 times faster than a comparable dense model, especially when you're working with long documents. You know that frustrating lag you sometimes get? It's basically gone.
Second, the cost.
By only activating a fraction of the model, the computational cost to train it and run it plummets by a staggering 90%. This makes high-end AI dramatically cheaper and more accessible to everyone.
And this might be the biggest deal of all. This is an 80 billion parameter model that can run on a consumer-grade GPU with just 24 gigs of VRAM. For perspective, a dense model this size would need over 160 gigs. This is what truly democratizes AI, bringing elite power out of a massive data center and right onto our desktops.
So why does all this matter? It means AI is becoming way more efficient, using less money and less energy. It's more accessible, running on hardware people actually own. This is going to fuel a whole new wave of innovation for developers. And crucially, since it's open source, anyone can build on top of this breakthrough.
Ultimately, Qwen3 Next proves that the future of AI isn't about getting bigger, it's about getting smarter. It's a fundamental shift in philosophy. So the real question is, if AI can be this powerful while using so much less, what incredible new possibilities does that unlock for all of us?